Okay, so let's solve this problem. So find the sum of this arithmetic series, and to find the sum of the arithmetic series, this is the formula. So in the given series, the first term is a sub 1 and the last term, that's a sub n. Then since from this formula we have the number of terms, and since in the given there is no number of terms, so therefore we need to solve first the number of terms on this series using this arithmetic sequence formula. And observe, from this formula we have the common difference. So we need to find the common difference, that's the difference between the two consecutive terms. So formula to find the common difference, that's a sub 2 minus a sub 1, or you can use a sub 3 minus a sub 2. So in the given series, the second term, that's a sub 2. So to find now the common difference, we have this 19 minus 13. So that's a sub 2 minus a sub 1. So therefore, the common difference is positive 6. So to find now the number of terms, so using this formula, that's a sub n, that's 85, then equals a sub 1, that's 13, plus n, that's the number of terms, minus 1 times the common difference, that's 6. Then simplify, so transpose this positive 13. So we have 85 minus 13, then equals, so multiply this 6, this one is 6n, then negative 1 times 6, that's negative 6. Then this 85 minus 13, this one is 72. Then transpose this negative 6. So this becomes positive 6, then equals 6n. Then this 72 plus 6, that's 78, equals 6n. Then to solve for n, so divide both sides by 6. So therefore, n is equal to, so this 78 divided by 6, that's 13. So therefore, this series has 13 terms. So this time we can solve now the sum of this arithmetic series from this formula. So since this series has 13 terms, so we have now the sum of these 13 terms, then equals n, that's 13, then divide by 2, times a sub 1, that's 13, plus a sub n, that's 85. Then we have this 13 divided by 2 times this 13 plus 85, that's 98. So the sum now of these 13 terms, so we have this 13, then divide by 2, equals, then times 98, equals, that's 637. So the sum of these 13 terms is 637. Then for this problem, so again, to find the sum of this arithmetic series, so using this formula, and in the problem, so the first term is a sub 1. Then since there is no given a sub n, so we still need to find the last term of this series. So using this formula, since we have these 15 terms, so therefore n is equal to 15. So first, we need to find the common difference. So this one is a sub 2. So we have 7 minus 3. So the common difference is positive 4. So to find now the last term, So from this formula, so we have this a sub n equals a sub 1, that's 3, then plus n. So n is 15 because we have these 15 terms. So 15 then minus 1 times the common difference, that's 4. Then we have now this a sub n then equals 3 plus 15 minus 1. This one is 14. Then times 4. Then simplify. So we have a sub n equals 3 plus, so this 14 times 4, that's 56. So therefore, the last term is positive 59. So this time, we can solve now the sum of this arithmetic series because we have all the values, the a sub 1, the a sub n, and the number of terms. So since we have these 15 terms, so the sum of these 15 terms equals 15, then divide by 2 times a sub 1, that's 3, plus a sub n, that's 59. Then simplify, so we have this 15 divided by 2 times 3 plus 59, that's 62. So therefore, the sum of these 15 terms, so we have this 15 divided by 2 equals, then times 62 equals, that's 465. So the sum of these 15 terms is 465.